Yes, let's look at the classwork to back up the experiment we just performed in the previous video. This is a JAMB question of 1986, question 19. 20 cm cube of 0.1 molar NH4OH solution when neutralized with 20.05 cm cube of 0.1 molar HCl liberated 102 joules of heat. Calculate the heat change of neutralization of NH4OH. Now the next thing to do is to convert this 0.1 to mole, not from molar. Molar means mole per dm cube. You want to drive the dm cube away and get only mole. So to do that, the formula to use is number of mole. Number of mole is equal to CV over 1000. So where our C is concentration in mole per dm cube, which is 0.1 molar, and our V is the volume, which is 20 cm cube. So we can go now. Our number of mole will now be 0.1 times 20 over 1000. Can our calculator press and tell us what is it? 0.1 times 20 is what?
0.1 times 20 is 2 over 1000. 2 over 1000.
This one is 2, Abi?
Yes.
2 over 1000. And our answer gives us what?
0.002.
002 mole. So, but one of the standard conditions for heat change is that the concentration will be 1 mole. Are we there? Not 0.002 mole. So we now say, okay, it is 0.002 mole of NH4Cl plus HCl release the heat of what in the question? The heat of 10 what in the question? 102 joule. Are we there? Then 1 mole of NH4Cl plus HCl will release the heat of what? The heat of X joule. So we turn this statement to equation. We now have this 0.002 mole over 1 mole is equal to what heat? 102 joule over X joule. We cross multiply, we have 1 times 102. And we have 0. This one times this one 0.002 x equal to 1 times 102. So we have 0.002 x equals to 102. So our x will now be 102 divided, we divide both sides now, divided by 0.002. So my calculator, pressure, what's your answer?
So, okay.
102 divided by 0.002. Answer is what?
51,000.
51,000 joules. 51,000 joules. Where's one? Okay. So that is the answer for that JAMB question. So we are moving very straightforwardly to spontaneous reaction. Spontaneous reaction. So what do we do to convert it to kilojoule? Divide it by what?
1,000.
Now let me divide it.
51.
Which is what? 51, Abi. 51,000 over 1,000. Answer is 51 kilojoule per mole. What are the options we have here? Option A, we have minus 51.0 kilojoule per mole. I want to show you something there. B, plus 57.3 kilojoule per mole. C, plus 57.0 kilojoule per mole D plus 51.0 kilojoule. What do you think will be your answer? What did we get?
51.
We got 51, which is plus, Abi.
Yes,
But I told you, because neutralization reaction is what? Is an exothermic reaction. By yourself, you used to have to do what? Put minus. Are we there now?
Yes.
So, we now say the heat of neutralization of NH4Cl will give us minus 51.0 kilojoule per mole, which is option what? Option A. Although in your calculation you got plus, but once it is heat of neutralization, you put what? Minus. Are we together? Yes. So please take note of that. So that is why the answer
is not a good concept because A is really minus A.
Okay. Well, if you say so, I pray that God will help you. No, wow, no problem. I hope you are done writing from the board. I want to wipe the board now. I want to go to spontaneous reaction. Can I wipe the board?
No, sir.
So let's go to.
Uncle, where it says? You're obstructing me.
Alright. Yes. Let's go to spontaneous reaction. What is a spontaneous reaction? A spontaneous reaction is a reaction that occurs without relying on any external source of energy. So a reaction that occurs, sit down one place, sit down somewhere. A reaction that occurs without relying on any external source of energy is called spontaneous reaction. Now let me tell you something. We have said before that exothermic reactions are spontaneous. Why? Because their activation energy is very low. Take note of something. Exothermic reactions are spontaneous because they have low activation energy. We have discussed that one before.
Yes, sir.
So, but don't look at those, and that's why it's exothermic. They don't absorb heat, they rather lose heat. Those ones that absorb heat now, that heat they absorb is what is helping them to react. That's why they are not spontaneous. Am I talking? Yes. But let me tell you one thing. Activation energy alone cannot be used to determine, or do you know that whether a reaction is exothermic or endothermic, it is the enthalpy change that makes us to know. Are we together? There is a question they used to ask. State the reason enthalpy change alone cannot be used to determine the spontaneity of a reaction, because some endothermic reactions are also spontaneous. Some endothermic reactions are also what?
Spontaneous.
Like when you pour ammonium chloride in water, the experiment you did last week, that your hand became very cold, as if you put ice block in your hand. Do you need to put that experiment on fire before it takes place? By itself, it takes place. Are we together? So now, enthalpy change alone, cannot be used to determine, stop that noise, to determine the spontaneity of a system. You cannot use enthalpy change alone to determine the spontaneity of a system. So why? This is because some endothermic reaction. Some endothermic reaction are spontaneous. So please, if they ask you that question, state the reason. Enthalpy change alone cannot be used to determine the spontaneity of a reaction. Tell them because some endothermic reaction are what? Are spontaneous. So then the question is that if we cannot use enthalpy change alone to determine the spontaneity, what other things can we now use to determine the spontaneity of a chemical reaction? So at that, in page 2 now, apart from enthalpy change, two other factors which determine the spontaneity of a system, keep quiet now, are 1. Entropy change, which is delta x, and number 2 gives free energy change, which means delta G. They can ask you in any exam, state 2 factors that determine the spontaneity of reaction apart from enthalpy change. You have entropy change and gives free energy change. If they say state 3 factors, you say entropy change, and gives free energy. Now, what is entropy change? Entropy. What's entropy change? What is entropy itself? Entropy, which is S. Entropy is the measure of the degree of randomness or disorder of a system. The degree of randomness or disorderliness of a system is called entropy. What does that mean? How gentle, what's it randomly? How gentle the particles are, or how scattered, that is disorderliness, the particles are. Am I talking to you? If I will use examples of religion, in the churches we have around us, if I ask you, out of Winner Chapels and Deeper Life, which one has a higher entropy than the other? Higher disorderliness. Winners now, they can be preaching and be raising shares like this. Right on, pastor. But have you been to the Deeper Life program before? They will sit down quietly. And the preacher will be preaching, Jesus is coming soon. And he's going with his saying. Everybody will be quiet. If you sleep, they will put a Bible like this in your head. You wake up. The entropy change in that place is low. They are not scattered. Then let's look at another example. Out of solid and liquid, which one has higher entropy? Solid. No, solid has lower entropy. Scatteredness. Entropy means how scattered they are. Solid have lower entropy, while gases have the highest what? Entropy. So entropy value now decreases from gases to liquid and to solid. So what we are trying to say here is that gases have the highest what? What we are trying to say is that gases have highest entropy value, followed by liquids, and the least is in solid. Am I talking to you?
Yes, sir.
So take note of that. Now, they can ask you some questions. Let me see whether I will see some jam questions here. They will ask you, is the entropy increasing or decreasing? Okay, if I ask you now, classwork, before I will check the jam question, classwork. Now, what happens? What happens to change in entropy if, number one, ice melts to liquid? Oh yeah, answer me. If ice melts to liquid, what happens to entropy? Ice, which is block solid, change it to liquid. Does it increase or reduce? Increases because it is low inside that ice block. Are we there now? Yes. So his answer now is that entropy value increases. Am I talking to you? Yes. So that is. What about liquid water? When liquid water freezes,
the entropy value decreases.
Entropy value decreases. Okay, let's check jam question and see what they have for us. In which of the following is the entropy change positive? Look at this, number 2. In which of the following is the entropy change positive? You know, another word for increase is positive. Another one for decrease is what? Negative. So here now, when you say the entropy value increases, you can say the entropy value becomes positive. Where you say entropy value decreases, you can say entropy value turns negative. So let's look at the question this jump is giving unto us. Option A, page 4. Option A, we have H2O liquid turns to H2O gas. Option B, Cu2 plus aqueous plus Fe solid equals to Fe2 plus aqueous plus Cu solid. C, N2 gas plus 3H2 gas equals to 2NH3 gas. Option D, 2HCl solid and gas. Okay. It is where, okay, let's say NH4Cl solid. What are they put solid there? The thing was wrong. Gas. Supposed to be NH3 gas plus HCl gas. This is how supposed to be. Okay, this is JAM 1992, question 26. Okay. Can anybody attempt that question? What is A?
Just says A.
They say which one is positive? I mean, from liquid
To gas.
to gas. Entropy increases, turns positive. Answer is A.
Yes.
What about B? Why not B?
Because
It's the same thing. Aqueous solid.
yes.
Entropy does not change.
But C is gas.
But C, gas, still form gas. When that happens like that, you want to know whether entropy increase or decrease. And the reactant and the product, everything is gas. See what we do now, check their number of mole. What is this? 3. What is 1? That's 4. Total number of mole is 4. The total number of mole is what? 2. So out of 4 and 2, which one is bigger?
4.
So when you have 4, we have more entropy. It's now reducing. Are we there now? Which is against our answer. Can you see that now? That's how to answer that. So please take note of that. What about this one? Solid. Solid. It's like solid to what?
Solid.
To gas. What does entropy does from solid? It increases. And top of this was going to be an answer also, but it was not correct here. They wrote something that is not correct. So I now thought this could be the answer. You understand? So that means this one is not the answer. But the reactant they gave me here is even totally different. So let me totally remove the D, option D. It's not correct. What they wrote there is not possible. They put 2HCl solid. Can HCl be solid?
You clean C.
I clean D.
You clean C too.
Okay. See now. See now I have what? 2Na3 gram. So answer is what? Is A. So now okay. Okay, look at this one now. Another jam question, number 3. They say NH3 gas plus HCl gas giving us NH4Cl solid. They now say the entropy change in the system above is what? A, 0. B, indeterminate. C, positive. D, negative. Please tell me the answer. JAM 2001 question 23. What is the answer there?
Positive.
Negative.
Negative.
We are moving from gas to solid.
Negative.
Gas, that's what negative, I mean?
Yes.
Yeah, it's becoming reduced. Because entropy in gases is more than entropy. Where's my duster? Where's my bottle cleaner? Where is it?
No.
Now, let's look at another one. Okay, let's look at another one here. Good. Now, next question number 4. Number 4, they say which of the following highest entropy value? A. HBr, B. HF, C. HI, D. HCl. This is jam. What's the answer here? What's the answer? A. What is your answer? Talk to me.
Which one follow the
Yes, answer is what? HF.
How?
Because fluorine in the periodic table is the most reactive, is the most electronegative. You see, remember in periodic table, yes, the most electronegative. So, and it is the lightest gas amongst halogen. Is a gas. Chlorine is also a gas. But when you move from chlorine down to bromine, it turns to liquid. From bromine to iodine turns to solid. Are we there now? So as we are moving down, entropy is what happening in halogen group 7.
Decreasing.
Is what is decreasing. Because the number one is fluorine, is a gas. Lightest gas among them. Followed by chlorine. Chlorine is thicker. Is 10. Followed by bromine, which is getting liquid. Then, so that is it. So that is that. So the next question here, they say when sugar is dissolved in a tea, what happens? The reaction is always what? Accompanied by what? A. Positive entropy change. B. Negative entropy change. C. No entropy change. Then D. A minimum entropy change. This is JAM 2003 question 21. Please, what's the answer here? What sugar is high? Sugar is solid. Entropy is low. When it is solid, when the sugar is solid, entropy is low. When you now put it inside water which has a higher entropy.
The answer is positive.
Positive. Thank you. God bless you. Option A.
Who is weak? I got it.
Now let me say something here. Let's talk about entropy as entropy change. As a state value, entropy as a what? State value. What does that mean? The entropy change of a system is given as what? Delta S equals to summation of change in entropy of products minus summation of change in entropy of what? Reactor. No, the same thing. Just like we did this one under another type of calculation now. This is calculation under entropy now. Hello? You know how to use this formula now?
Yes.
We did similarly under enthalpy. But the difference is that in case of enthalpy of element is 0. But entropy of element is not 0. It will be given to you in question. Let's start the class work here. Now look at this question. It says Calculate the entropy change when CaCO3 decomposes to give CaO and CO2. Given that S theta of CaCO3 is 214 joule per mole per Kelvin. Entropy of CaO is equal to 39.7 mole joule per mole per Kelvin. Then standard entropy of CO2 is equal to 214 joule per mole. 214 again. Okay, this one is 90. This is a 92.9. So this one is joule per Kelvin. So now they expect you to write the equation by yourself. We have 81.4 joule per Kelvin, B 160.8 joule per Kelvin, C 81.4. Okay, this one will have the minus joule per Kelvin. And D 1 minus 160.8 joule per Kelvin. Yeah, this is a JAM question. JAM 2018 question 15. Yes. Are you done writing? To do that and push them forward. I can even send them away. I may not even teach them. You are the most important people to me. Those SS1, they are still sucking breast. They don't know what life is. They are still sucking breast. Okay, now let's look at the solution to this problem. Yes. Okay. First thing first is to write the equation to know whether you are going to multiply any of the entropy by any number that they use to balance each of the quantity. Here they say calculate the entropy change when calcium carbonate from the calcium carbonate when it decomposes is a solid. Decomposes. The decomposition will give you calcium oxide and carbon 4 oxide gas. The equation is self-balanced by itself. Abi? Yes. Self-balanced. So what we have now is what? The formula is what? Entropy. Standard entropy is equal to sum of entropy change of products minus sum of entropy change of what? Reactants. What is the sum of entropy change of products? What is cow? What is cow? In the product, entropy of calcium oxide. What is the entropy of calcium oxide? S theta cow is 39.7 plus CO2. CO2 is 214, Abi. This make up the what? The product. Yes. Cow and CO2. Are we there? So then minus what is the reactant? Cacotiri. The heat of cacotiri is what? Minus is what? 92.9. Are we there? Yes. So add up these two things now. 39.7 plus 214 is what?
39.7 plus 214.
Yes. Press. Huh? 253.7. Now minus 92.9. What's our answer? We are going to get a positive answer, meaning that the entropy increases.
Yes.
Abi? Even from the equation. From the equation. Hello? From the equation, we are moving from solid. This is gas. This is gas. This is gas, Abi?
Yes.
Look at this now. Even from the equation, hey, we are moving from solid to gas. Entropy is changing. Solid has a lower entropy. Gas have what? Higher entropy. So that is increasing. That's why we are getting a positive number of a plus. That's why you must put this plus. Madam, you were asking me that question which day. You must put this plus. Plus what? What's the answer?
108.8.
0.8 joule per Kelvin. And that's option what? Option B. So that is what we have there. Now let's now go to Gibbs free energy. Gibbs free energy. In fact, I am fulfilled. We are moving with understanding. We are not just rushing. Abi? Yes. Information is sinking. Those who are not here now, it is well with their soul.
Amen.
Now, what is Gibbs free energy? Gibbs free energy is the energy available for doing work. What is free energy? Energy for what? Available for doing work. That's not free energy. No, since it is energy, it also has the same SI unit as enthalpy change, which is kilojoule per mole. So now, then we have free energy change. Gibbs free. This is G. Gibbs free energy change. What is free energy change? This is the difference between what? Between the energy, free energy of product and free energy of reactant. Am I correct?
Yes.
Is the difference between the sum of the Gibbs free energy change of the product and that of the reactant. So we can say delta G theta is equal to sum of this free energy of product minus delta G theta reactant. So there are three places. They can also still give you free energy for an equation. You know what to do when you have this. Abi? So that is it. Then there are things also we need to know. Note. Facts to know. Facts. Okay, let's look at relationship. Relationship between enthalpy change and enthalpy change and entropy change. Between enthalpy change, that relationship is what? Delta S is equal to delta H over T. where delta S is entropy change. Entropy change. And delta H is enthalpy change. Let's look at for a jam question that can give us question like that. Classwork. Okay. Now let's look at this question. Given that HCl plus NaOH equals to NaCl plus H2O, and that's a delta H equals to minus 57.4 kJ per mole. Now, if the reaction occurs at 25 degrees C, find the entropy change of the reaction. They are giving us the enthalpy. Delta H is equal to what? Minus 57.4 kJ per mole, which is this. Then they are asking us to find delta S, and our temperature has been given to be 25 degrees C plus 273. What's our answer? Press. 25 plus 273 is what?
298.
298 Kelvin. So our formula is delta S equals to delta H over temperature. Delta S will now be, what is delta H now? Minus 57.4 over 298. What's our answer? Minus what?
Minus
57.4.
7.4 divided by minus
1.8. When you have 57 divided by a bigger number, 0 point now. 57.4 divided by 192. So, okay, that is a joule per Kelvin. So that is that. Now let's now look at relationship between relationship between the three of them now. Between delta G, between free energy change. Free energy change is delta G, entropy change. Entropy change, that's delta S, and enthalpy change. Enthalpy change, that's delta H. Now, the relation between them is delta G equals to delta H minus T delta S. Please look up where delta G gives free energy change. Then delta H is enthalpy change. It's okay. Then T is temperature. And delta S is entropy change. So let's look at facts about free energy. change. Number one. Okay, if delta G, number one now, if delta G is negative, it means that the reaction is spontaneous. Take note too. If after getting your answer for delta G, it must be negative. For when it is negative, it means no work is done. You know, free energy is what? Is the energy available for doing work. That is, the work, if a system cannot take place by itself, are you getting it now? That system is not spontaneous because it relies on the energy available for doing work. Am I talking? Then that means delta G will not be positive. Then that means that reaction cannot take place spontaneously. It can take place, but it needs help. Delta G must be positive. So if number 2 point now, number 2 points, if delta G is positive, the reaction is not feasible spontaneously. Then point number 3, if delta G is 0, the reaction is at the state of equilibrium. The state of equilibrium. Then, first law of thermodynamics. First law of thermodynamics. This law states that energy cannot be created nor what? Destroyed. But it can be transformed from one form to another. So, mathematically, you can represent this statement mathematically. That delta U equals to Q plus W, where delta U means what? Internal heat change of a system. Delta Q means heat gain or heat loss. Delta W is work done on the system. So for a gaseous system, we have delta U equals to delta Q plus PV, where P is pressure and V is volume. So let's look at class work and call it here. Yeah. Oh, yeah, right fast. I can clean it now. reaction takes place spontaneously if what happens? If A, delta G is 0, B, delta S is less than 0, C, delta H is less than TAS, D, delta G is greater than 0. Jam. So I should have told you here. Where was I talking about delta G that time? In this place, for this reaction to be spontaneous here, delta G must be negative. And it occurs if delta G is less than delta, is less than TAS, okay, is less than TAS. Oh, but this one, they repeated this one, okay, this is now supposed to be negative. So answer would have be what? Negative. This is JAM 1992, question 26. So please master those statements that are there. Now they say 1/2 N2 gas plus 1/2 O2 gas is equals to NO gas. Delta H of this is 89 kilojoule per mole. He now said if the entropy change for the reaction above at 25 degrees C is 1.8 joule. Calculate the change in free energy, delta G. A 88.71 kilojoule, B 85.48 kilojoule, C 204.00 kilojoule, D minus 34227.40 kilojoule. So this is JAM 1997, question 26. Let's solve this question fast. Okay, here is good now. So to solve this solution, so you have to know the relationship between all those things. What's the relation between delta G? We have delta G equals to delta H minus T change in S. This is a relationship. You see, remember? Then what did they give us as delta G? That's what they say we should find. We don't know it. What's our delta H there? Our delta H there is what? 89, Abi. 89 kilojoule per mole. Then our temperature is 25, right? Which is at 25 plus 273. What's our answer? 25 plus press. Calculator. Press now. Press. Stop writing and press now. 398. 298 Kelvin. Then our entropy change equal, what's it in the question? 11.8, right? 11.8 joule. So what is it? We can put it in our formula now. Delta G equals our delta H now. 889 minus 298, which is temperature, times what is our entropy? 11.8. So delta G now, what is now 89? We have 298 times 11.8 is what? Press.
One option. And what is the
change G equals to minus G?
Yes, what's the answer? 35.4. So delta G now, yeah, take this away. Now minus what?
minus 342.4.
342.4. So answer is what? Joule. That is D, option D. It says C plus H2O gas equals to H2 gas plus CO gas. It now says delta G for the reaction above at 1300 Kelvin is minus 43 kilojoule. At this temperature, the reaction is not feasible. B at equilibrium. C feasible. D exothermic. This is JAM 2009, question 25. This will be the last question. I think we have tried. So let's solve this and call it a day. Yeah, where are we cleaning here? Yeah, that's what we are doing here. What's our formula? Delta G equals to what? Delta H minus what? T change in S. What's our delta G? According to the question, they say delta G for the reaction above at the temperature is what? At the temperature of what? 1300 Kelvin is what? Minus 43 kilojoule, right? Yes. And in the front, did they give us anything delta H there? At this temperature, the reaction is what? Okay. The delta H is not given. That means we have to look for delta H. That means we have to look for what? Delta H. We have to look for delta H, is unknown. So what do we do? In place of delta G, what do we put? Minus 43. is equal to, we don't know delta H, minus temperature is what? 1300 times what is entropy? What is the entropy? Will you not give us entropy also? Let's check. Now let's solve these ones. Yes, that question we were discussing, this one, it doesn't need any solving. We're not solving ourselves, writing out some things. Look at this. If the entropy change for the reaction at 1300 is minus 43, when entropy is negative, what does it mean? The reaction is what? Occurs spontaneous. Is it not free energy? Okay, this is entropy for the reaction. Okay, if the entropy change for the reaction at this one is this one, at this temperature, the reaction is what? Is A not feasible, at equilibrium feasible, exothermic. Is it entropy they want to say here, or free energy change? If the free energy, they want to say, if the free energy change for the reaction, if free energy is negative, then the reaction will occur spontaneously, is feasible, right? The reaction is feasible, no need for calculation. Then number 4, the reaction above is carried out at 25 degrees centigrade. If the delta H, let's write our parameters. So number 4 now, delta H I'll be given to the world is minus 72 kilojoule per mole. That is the negative, and delta S entropy is what? Minus 106 joule per mole per Kelvin. Are we together?
Yes.
Then they now say what? The reaction will do what? Then we need to find the entropy for us to know the condition of the reaction. Entropy, we need to find the B free energy. B free energy is delta H minus T change in S. Our delta G is what is enthalpy? Minus 72 minus, don't ask me question later, I will talk well. Minus temperature. And they say the temperature takes place at 25. So 25, that means convert to Kelvin. 225 plus 273, that's the temperature. Then times what is the entropy? The entropy is 106. So delta G will now be minus 72 minus, add up. You say this one is what? 298 times 106 now. 298 times 106.
31588.
31588. So what is minus this one minus this one?
Minus 3160.
It must increase, oh. Plus 72. Carry 1 each. 9 plus that 6. 513. So
316060.
31560.
No, it's not 31560. It's 31660.
660. Finish, Abby?
Yes.
So then that is a kilojoule per mole. Now at this, what is when your delta G is minus, reaction is what? Spontaneous. So what is the answer? Proceed spontaneously. Now, then number 5. A chemical reaction with entropy change of 20. A chemical reaction with entropy change of 20. Entropy, that is delta S, is 20. 20 joule per Kelvin. And free energy, delta G is what? Plus 55,000 joule. Occurred at the temperature of what? The temperature is minus 23 degrees C. Which is equal to what? Minus 23 plus 273. What's the answer? Oh yeah. Take 23 away from here. What's the answer now? Are you pressing or writing?
Okay.
Minus 23 plus 273.
250.
250 Kelvin.
Yes.
So put in your values. You have delta G equals to delta H minus T change in S. So our delta G now, and delta G is what? It's already given to be what?
Plus 555000.
55000. Delta H is unknown. That's what we are looking for. Minus temperature is what? 250. Times entropy is what? 20. So we have 55000 equals to delta H. 250 times 20 is what?
500.
20, not times 2.
5,000.
Press it now. Press it. Don't use head.
No, it's
5,000.
5,000.
Yes.
5,000. So take this one here. You have 55000 plus
5,000.
5,000.
The answer is 60,000.
What's the answer?
60,000.
60K.
B.
Okay, equals to delta H. So our delta H now is 60,000. 60,000 watts?
Joules.
Joules. That's option D. The last question. So that I can attend to the SS1 students. Okay. Here is going now, right?
Yes, sir.
So we said for a chemical reaction to be spontaneous, we don't even need calculation. Why am I cleaning the board? For a chemical reaction to be spontaneous, delta G must be what?
Negative.
Negative. Thank you. God bless you and bye for now. Thank you. So in the next class now, we'll be going to chemical equilibrium.